Ladies and gentlemen, welcome to today's webinar. Good morning or good afternoon, depending where you are on the planet. Today we are going to talk about carbon capture, also the market outlook. This webinar is the second session of the same webinar that we did last week. Unfortunately, and I'm really sorry for this, last week it happened that we were a little bit, victim of our success. We had more than hundreds of connections. It seemed our team was a little bit restricted. So anyway, today we open the flow so everybody will be able to connect. And of course, as always, you will be able to find our webinar online. We publish it on our website. So if you want to see this webinar or the previous one, do not hesitate to go check on our webpage, tobefirstconsulting.com, to see all our content. Before starting and going to the point of this webinar, just few recalls. Of course, I present this webinar. If you have any question regarding the content, you are able to ask directly in the Q&A section of Teams your question. I will address all the questions directly at the end of the webinar itself. So do not hesitate to start to type your question during the presentation, and I'll take all of them at the end. In the meantime, if you're interested by the slide that I'm going to use today, shoot me an email at the address you will find in the conversation. It's guillemjean@tobefirstconsulting.com, and I'll be pleased to share the slide with you either today, either by tomorrow, so you will be able to have them, of course. So time is running. I see a lot of people are connected already, so let's start. Just few information. Our next webinar has already been published. It will take place on the 2nd of November, 2 p.m. same timing, and as it will be the end of the third quarter of 2021, we'll take time to make an oil and gas and petrochem market update. And of course, the idea is there to see what has been already happening on the year, what will be happening on the last 3 months of the year, and of course, give some outlook about the following year, 2022. Here you will find the link to our LinkedIn and also to my address email. If you want to receive the slide again, do not hesitate to shoot me an email straight away. The agenda for today is quite clear. First, we'll take care of the introduction, who we are, what we're doing, let's say spirit behind what we are doing. Then we'll talk about what's the trends. We'll also then talk about the technology, the type of project we are currently expecting, and we are developing as well. And then we go to a more business side. Let's say what is today market, what are the 5 years outlook. Then we'll look on the 10 years outlook, and of course the 30 years outlook. So of course today we are going to cover all this topic. Let me have the introduction straight away. Myself, I am Jean, and I work with Jean-Charles. We are both engineers. We are working for a company named To Be First Consulting. Our company has developed a tool called Project Smart Explorer, and it's a database where we refer all the energy projects that are going to be built. You can see many logos in our description. That's some places we have been working in. Siemens for myself, ABB with Jean-Charles. We are in many cluster and association, and we are regular publishers of technical paper over the energy project, but also market analysts of the oil and gas business, but also on decarbonification and the energy side. Some information about the database itself. The idea is to cover with 1,000 projects, all in pre-FEED and in FEED stage, all the oil and gas, petrochem, renewable, and decarbonification project. The aspect I would say with those projects is that we are simply covering, or simply not simply, but we are covering and focusing on projects at pre-FEED and FEED stage, really meaning the early design of those projects. The idea is to give you the early information as soon as we can have them, to be sure that you can interact with those projects and you are sure to get an advance on this. So of course, you can find, let's say, I would say the common scope in oil and gas, what is upstream, what is midstream, also all the downstream with petrochem, all the fertilizer. But you can also see what are the new, let's say, projects, what we call in electrification, carbon capture, hydrogen, solar, windmill, power generation, and also water treatment. As of today, we cover already 40 applications in this new industry. We have all the electrification project, of course, all the carbon capture project that we are going to talk about today. We are going to talk about, of course, the capture, the transport, and the storage itself. And then in our scope, we also cover what is hydrogen, all the solar, the windmill, power gen, and water treatment. So this is the scope we already have in the database. And that's a little bit a news, but we added more than 20 new applications this week or last week to cover also what is waste to recycling, also what is the transport of hydrogen, also all the project about energy storage itself, and many hydrogen variants where you can find power generation, all the methanol application, ammonia, and also some included, or I would say all-in-one application with wind to hydrogen. Going from this slide, so you can see Project Smart Explorer is today a database which was earlier covering only the oil and gas and petrochem, and today we are really trying to focus on this energy transition, and this webinar is part, of course, of this trend where we try to really help our customers, but not only, all the sector of energy moving in this transition and takes the best opportunities of it. As you will see today, it's moving fast, and of course, we are trying to have the full scope of this energy transition. If you're interested by this, do not hesitate to send me an email, and of course, we can detail all those applications and see how we can work together. Now, going to the heart, I would say, of today's webinar, we'll talk about the carbon capture, the need and the trend. Just a first slide to give you, let's say, some piece about the wording, what is under this umbrella of carbon capture and storage. As you will see, I'll talk a lot in my wording. I will use and abuse of carbon capture. Of course, behind carbon capture, I will cover also the storage, the usage. So you can find different naming. It's quite important to understand what is behind. You can find the wording CC, which is carbon capture. You can find CCUS and CCS. In those two last, I would say the U can stand for two things: utilization or usage. Both are the same meaning, but it's just two different words you can find. Same story for the S itself. It can be used for sequestration or storage. Ourselves, we will use storage today, but I mean, both concepts are the same as well. It's just that you can find the both wording. The idea behind carbon capture, it's a whole value chain, and ourselves, we represent it in, let's say, three categories. Really try to put what is the capture, what is then the transport, and at the end, what is the storage. I put you a little schematics that I found, really from, let's say, the production of carbon to its, let's say, end, which are storage and utilization. In between, we'll not talk too much about utilization and usage. If you have some question about it, of course, feel free to ask them directly in the Q&A section. Why we will not talk about this is because it's quite early as of today. Technology are not mature. It's more laboratory tests that we see more than actual business and project about it. And then, of course, the main mantra today, and that's the reason for carbon capture, the idea is to prevent global warming by not releasing all the carbon gas directly in the atmosphere. So where is the need coming from? And I really used to explain this, a slide that you may have seen during our presentation on hydrogen. Today, if we split the oil consumption per sector, you see many applications: road passenger vehicles, road freight, aviation, marine transport, steam, process heat, petrochem, buildings, and many other applications that we find in the energy sector as a whole. Of course, for many of those applications in the energy transition, electricity will replace many oil and gas applications. Also, some of the applications which are not covered directly by electricity will be covered by hydrogen. But still, even in using hydrogen and electricity, you cannot cover all the application that we have in the broad portfolio of oil. And just for the simple task, for example, I've got here a plastic pen, and you cannot produce a plastic pen just by using electricity and hydrogen. Of course, you need the oil as a first, let's say, supplier to produce the plastic and more. And the idea behind the carbon capture and storage industry is to maintain those applications that are needed for our life, I would say, and lifestyle, but in a way that we maintain those applications in the energy transition scenario just by cleaning them. And in fact, if we look at the number on the next slide, I really try to capture a graph explaining how much greenhouse gas is expected from the production worldwide. And in those applications, here you have, it's really detailed, and it's quite a figure I was seeing interesting. If we take at the total of global greenhouse emission, it's about 50 billion tons of CO2 equivalent. Now, if we go into detail, I mean, just taking about what is used for iron, petrochem, for power generation by gas turbine, for chemical plant, for cement, and other industries, it happened that it represents around 47% of the emission of CO2, which is massive. And in those, I didn't made and I didn't had in this calculation all the emissions which are made by transport, which are not localized. Meaning in transport, I will put all what is road transport, shipping, and aviation. So putting them aside, you already see that just so many on the left of the slide, you represent half of the CO2 emission. So it means that the carbon capture, where the electricity might not apply, where the hydrogen may not apply, carbon capture will be a way for those applications to survive and to be maintained in a clean way. And why it's possible? Because those high emissions are concentrated in few locations. It means that, for example, power generation, gas turbine are huge emitters of CO2, but there are one spot where you have all the emission. And that's where it's making sense for carbon capture. It's because you can reduce your carbon footprint in just one singular area and then capture your carbon and make something not harmful to the environment with it. Just to give you a figure, I'm really trying to push some figures to give you some idea about the market. In the European Union, there is about 2,000 locations and facilities that represent 1.6, 1.7 billion tons of CO2, which is huge. Which is really huge when you see the emission of Europe. And it means that by just, for example, adapting those facilities either to electricity, to hydrogen, or to carbon capture, you could reduce EU footprint in a massive way just by having those few revamp on project. So that's why it's also interesting with this market, is that the CO2 emissions are really well concentrated. And of course, you are not going to apply those carbon capture project to, I would say, a domestic vehicle, because it's way too few, let's say, volume of emission. So now, as we start to understand the need about carbon capture, of course, the question is also now to understand the trend. Why are we seeing carbon capture now? I mean, the simple reason is that government want to clean their carbon footprint and also keep the industry. Industries are vital for any country worldwide to have a developed economy, to have a developed lifestyle, to create value on your ground. And there is no way that you are going to close down your whole industry process for the energy transition. The idea is to do both things to help your industry to make this energy transition. And many investments are injected today as part of the energy transition, of course, as a booster from the COVID era, when government wanted to re-inject money on the table and in the economy, they were really happy to do in carbon capture and storage. And it's a great mean, I mean, to have some, let's say, pilot and demonstrator to clean your economy. And today, the motivation are quite simple for those governments. We see a lot of, let's say, survival aspect. I mean, everybody wants to save the planet. So it's a really strategic way to do it. And it's a mean. We cannot do everything with electricity and hydrogen. So carbon capture is a mean to save the planet. Also, it's quite important for industries because all the big industries worldwide have today the mandate to clean their carbon footprint, and they have to say they are able to reduce their carbon footprint by this much every year. So of course, they are quite interested in implementing those projects. And of course, it's a brand new, let's say, value chain and supply chain. So the idea is the first will take it all, and the idea is to be the first to develop the technology, the supply chain, and also the infrastructure. No, I would say the race and the tactical aspect would be what is the business model behind carbon capture, but because as you may know, it's not created value today. It may change in the future if there is some carbon tax, but today it's still in discussion. It's not applied, I would say, on a world scale, but no big industrial can escape from the risk to have a carbon tax. And of course, they have to be ready to prepare this and to address the topic. So now, let's say that we have understood the need and the trend behind those two topics. The idea is to go on the technology. What are the project behind? What are the content? Just by starting by, let's say, the roots, it's important to realize what are the strengths and the weakness of the supply chain. First, by going on the strengths, it's a really well-identified gas responsible for global gases. It's about 6 to 10 gases that are really responsible for all the harm we do to our planet. And so, I mean, the culprit is there. We know about it. No, it's quite also easy to evaluate with carbon capture, zero emission cuts. You know, sometimes companies have hard to make a communication about how much savings and CO2 savings they are making by, for example, turning to solar energy or to hydrogen. Here with carbon capture, it's quite easy to calculate. You capture this much of CO2, it's reinjected on the ground, and there you have saved your carbon footprint by a huge volume. So it's quite easy to see, I mean, the direct effect of your project, and that's a way also to market your project. Also, that what we see that those gas were responsible for global warming. They are very stable gas. At the example of the CO2, it's super easy to handle. It's quite stable. I mean, it's one of the easiest process you can have. And the second aspect is also that it's really located, as I was saying before, most of the, let's say, emissions are located in the industrial environment where you are able to do project and revamp to capture this and to handle those CO2 at large volume. And also, in the projection that we have, we estimate that this business will be quite comparable to natural gas with the same organization, with the capture, the transportation part, and also the storage. So it will be a little bit the opposite of what natural gas business is in terms of flow of gas, but then the idea and the spirit will be the same. Now, the weakness of the supply chain, and we try to tell the truth. That's the first one is clearly the economic value. Today, nobody is going to pay you to store CO2. People are trying to find some business. For example, if you go to a pump and you fill your tank of gas, you pay an extra credit to be sure that you are injecting on the ground the CO2 you are going to emit with your car. That's some business model we have seen. None of them have been yet proven. I think it will come, but this economic business is a big question because for let's say private investors, of course, as it does not create value, it's not done as simple as that, and that's why we also see in the financing most of the financing done by public governments or let's say European Union and big complex like this. Also, part of the supply chain is the technical specificities. When you want to capture, for example, CO2, you have to separate it, and it's from other gases, and it can be quite complex. And then, of course, I would say it's, let's say, more maturity problems where the supply chain is not existing yet, or the norms are not existing, but still it's quite easy, and I think we're in a good way to achieve this. And the last part is that to execute a carbon capture and store your CO2, it consumes a lot of energy. So the idea is to say, okay, and to benchmark what is the benefit from it. Because if you emit more CO2 than you are going to capture and store, there is no point in doing it. So you have to do it in a smart way to be sure that it's beneficial for the environment. At the end, it's not only, let's say, a communication exercise. No. Talking about the gas that needed to be captured, because we talk about carbon capture, but what is really behind, what is the harm, what is really the logic behind. I put there a table, which might be a bit small on your computer, but I will just explain it in detail. You have on the first column the gas responsible for greenhouse effect. Of course, the first culprit is CO2, carbon dioxide, but you'll find also methane, nitrous oxide, and many other terrible gases. The second column gives you, let's say, their global warming potential. It will be an index to say, okay, how much harmful they are to our environment. So of course, CO2 is, let's say, the benchmark, so it will be an index of 1. But here you can see that methane is 25 more dangerous than the CO2. And then you see this number is increasing by the list of gas, and some are around 22 times more dangerous than the carbon dioxide. So here, the first analysis is to say, okay, we have to handle carbon dioxide. That's a big topic, but some of the gases have also to be handled, and they are sometimes way more harmful to the environment than the CO2 itself. The third column is the volume of emission from those gases. And here you see that the CO2 represents 3/4 of those emissions, but methane represents already 16% of those emissions, which is huge, given, the index of potential harmfulness it can be to our planet. And you see that the other gases are more or less minor in terms of emission. But if you combine in the last column, let's say their potential harm with their percentage of emission, you see that the CO2 is representing only a part of the problem, and those other gases are way more dangerous to the global warming story that we are going to talk about. So it's really important to understand that in this market, of course, the main topic is about CO2. That's, I would say, the most well-known culprit that we have. But there are also gases that are more damageable and more dangerous than CO2. And we also have to take care of them. And that's a little bit the two sides we see on the market. We see small carbon capture projects which are in specific application, which are going to release those few gases which are super dangerous, but in small volumes to the environment. So those would be really niche project, really technical, but where the equipment and the capture would be really critical because they are the most dangerous one and they are the first one to address. And then you will see other projects which will go more in volumes, will be more in industrial scales, which will target the carbon dioxide or the methane, where we see more volume of, let's say, gas to capture. And there, of course, it will be more industrial. But we will have both projects on the market. And of course, some will have specificities as a really small niches. Some will be just, let's say, the broad market for carbon capture. So it's really important to focus by the project, which gas we are talking about, because the story and the process will be, of course, quite different in both cases. No, as I was saying at the beginning, we kind of broken down the let's say the entire supply chain between capture, transport, and storage. And here we are going to talk about the first topic, which is the capture. The capture can be done in 3 ways. I would say it can be done pre-combustion, meaning before the combustion of carbon gases or fuel. It can be done oxy-combustion during the combustion itself, or it can be done post-combustion. The idea and the concept is quite different. Either pre-combustion, it means that you are going to claim and take the carbon before it has been burned. So you really have to have a clean fuel, and in this way, you're sure that you are going to capture between 60 to 70% of the carbon. Then oxy-combustion, here the concept is that you are going to add other fuels to force your output gas of combustion to be pure carbon, and there you will have no separation to make. The idea is, for example, to add steam and pure deoxygen to be sure that you're generating 100% of CO2, and in this way you take all your output flames and you just take your smoke and you inject it on the ground. And the last concept, which is the most used, is to say, okay, we have done our flaming process, for example, and post-combustion, we are going to remove the CO2 from the other gases before it's released to the air. And there, the first advantage is that for existing plant, you can retrofit a unit of post-combustion, and then you just need to separate CO2 from the other gases, and usually you can separate and have, let's say, capture of 90% of the CO2 emission. And that's most of the project, for example, we see for blue hydrogen or carbon capture project on petrochem examples. And the idea behind this post-combustion is, of course, to make the separation from the carbon itself to the other gases. And this, you can do it in three ways. There are three existing technologies today. I'm going to lead them, but not go in the detail. The first process is, of course, to have amine absorption. That's a chemical process where you have the CO2 under pressure and the CO2 mix into the liquid phase, and the CO2 is stored in your liquid. Then you have the ammonia absorption. Here, the idea is to put the CO2 to make it react in a chemical way to create a solid molecule, which is NH3CO2H2O. And there, of course, when it's solid, the carbon is quite easy to store and capture. Or to capture and store, sorry. And the last one, which is in great development with really good prospects to my own understanding, it's the membrane separation. Here, the idea, and that's the picture you have on the slide, is that you push all your emissions through a valve, and here a membrane of nanotechnology will filter the CO2 from the other gases by permeability, and in this way you will be able to reclaim at the output a gas which will be CO2 free, and the CO2 will be stored directly into the filter and your membrane in the middle. Usually, when we look after combustion, the CO2 represents around 20% of the blend. The rest is steam, nitrogen, and sour gas. And the idea is really to make the separation, because if you need to store all those gases for nothing, because steam, nitrogen, and some sour gas are not super harmful, the idea is that you are going to store way too much gas, is going to cost you way too much. So the idea is to remake the separation as soon as you make the capture, to be sure that you are not going to transport gas which are not harmful. Talking about transport, here you see that there is three ways to do it, which are quite, I would say, logic and easy to understand. Of course, the first one is a truck. Like we have a gas truck or a gasoline truck. Super flexible. You can do small or medium volume to local area. The technology is already existing. It's flexible, it's cheap, it's quite convenient. Then many pipeline. The idea here with the pipeline is, as we're seeing, carbon capture will first develop into industrial park. And in many industrial park, you can see and you can have a pipeline of distribution, for example, for natural gas, for hydrogen. And the idea is to double those pipeline installation in a way that in one sense you have a flow of hydrogen pouring, and in the other one you have your CO2 coming back. And there you just need to double the existing infrastructure to be sure that your pipeline is coming up and coming back. And here it's quite easy to do. CO2 pipeline are something that are quite convenient and easy to build. They don't require, let's say, high pricing infrastructure. Even if you have a leak, as it's a big molecule, it's quite easily undoable. And the last part is that you can use ship to store, because as we were saying, there is a huge market, for example, for natural gas. And the idea in all the supply chain is to say the ship will go from the LNG production site to LNG terminals, for example. They will discard their natural gas, and then they will take back the carbon. They will refill their ships with carbon, and they will ship this carbon offshore to some storage location. So it's quite independent, flexible as well. You can collect and transport a huge volume of CO2. You don't have to revamp existing ships, for example, LNG carriers. You can just use them in the same way. And of course, many independent actors can operate in this strategy. Now, after the transportation is done, we're of course going to talk about the storage. The storage goal is quite simple, is to isolate the carbon from the atmosphere, and the way to do it is to inject this carbon on the ground. After the injection is done, it can serve for three purposes. Either you just leave it there and it will deteriorate over a long period of time. Either you can participate in ancient oil recovery, which is today a well-known practice for oil and gas operator, or it can be stored for a close future where this CO2 will be transformed back in plastic, fuel, and concrete. So the idea is to say, okay, to have not a permanent storage, but just a transition as a buffer, as we expect the CO2 to be used in the coming 10 years as a first feeder for later things. Just a point about the reservoir. Today, we have identified about 500 years of reservoir capacities. If we were capturing all the CO2 we produce, so you can see that we have more or less unlimited already reserves of capacities for carbon storage, which is a good news. And those reservoirs are natural cave, depleted oil and gas field. Coal means saline formation, saline aquifers, or sometimes also oil and gas field in operation. Two methods can be used for the injection. So to be sure that you store, you need to inject the CO2 underground. It can be done both ways. Either you have a rock reservoir, which with a high permeability in a layer of rock, and this way you can make a gas injection. It's quite easy. You just have to drill and you push your CO2. Or in all the other cases, you will have to inject your CO2 with a liquid, with water. It's even more efficient if the water is brine because it maximizes the volume of carbon you can store because you can go to high temperature and high pressure in all your reservoir. And of course, you can expand in all the reservoir with the liquid. When it's a gas, it's naturally the case. Once it's stored on the ground, we estimate that the leakage of CO2 is about 1% on the period of 1,000 years, meaning that it's really marginal. And for out of accident, I would say most of the reservoir will just keep and store the CO2 forever, which is, let's say, a good news. No, different type of sequestration, and there we go a little bit, I would say, beyond the storage itself. The idea is to say once you have injected the CO2 on the ground, what is happening? And it's a little bit a step effect because here you will have 4 processes which are going to happen a little bit one after the other. The first, I would say, method of storage and sequestration is structural. You inject CO2 on the ground, it's trapped into your reservoir, and that's it. The CO2 goes down your pipe, then goes up in the reservoir, and is stored there because you have an impermeable layer. First step. The second step, which will happen more or less in the same time, is the residual storage. It means that when the CO2 goes up in a reservoir, the CO2 molecules will be trapped in the pores of the rock. You know, like in all the rocks, with the water, the high pressure, and the high temperature, those rocks are quite permeable itself. And of course, CO2 will be trapped in those micro holes that can happen in your reservoir. So that's the second step. It happens also immediately after the injection. It's just stored there and it's trapped forever. Then the dissolution process. That's a little bit a more long-term mechanism. It's around medium range. And here the idea is that as you are going to inject the CO2 with the brine itself in the reservoir, the brine in the reservoir is going to absorb part of the CO2, and by dissolution, the brine will get heavier, which means that your volume of brine will go down because it's heavier, and will go to the bottom of the reservoir, will not be pushing at the top as a gas itself, and it will open more storage capacity in the reservoir by filling the reservoir by the bottom. But anyhow, you have this medium-term storage mechanism, which is super efficient. Then the last one, which is super long-term, it's over thousands of years, is the idea that the carbon dioxide will at a point bind chemically with its surrounding, meaning that with rock and it will itself become rock. And there it makes the carbon capture and storage irreversible. It's a long-term mechanism, and it's just filling, let's say, your reservoir with rock itself. Enough with the technical side. Now we will talk business, of course, and that's what matters the most for you. Here are, let's say, today and the 5 years expectation we see from this market. Here I exported the map from Project Smart Explorer from our tool itself. And you can see on this map, all the dots, all the green dots are projects all over the world. So I know it's small, but just to give you some information and some detail and comments about this, you see that projects are not happening all over the world yet. It's really located. And those locations are quite easy to identify. They are the US and Canada. They are the North Sea in Europe. They will be around Qatar, Saudi Arabia, and also the United Emirates States around this Arabia Peninsula location. And then you will find few projects in South Korea, China, Japan, and few large-scale projects also in Australia. So you see that with 5 regions, not to say countries, but 5 regions, that you are going to cover all the carbon capture projects and storage around the world. Why so is because let's say the first mover on those projects are, of course, the developed countries, the one which are able to invest on projects which are not creating value yet, but which will create value in the future, and also projects which are interested in reducing their carbon footprint. So those projects are, of course, pilot, demonstrator, but with huge incentives from countries. So they are quite, let's say, well financed. The idea is really to get those first opportunity to go on the market. Going in the detail of those projects, most of those projects are revamp of existing natural industrial plants for capture. They can be, for example, we see many gray hydrogen projects, which are huge emitters of CO2 and methane, just getting revamped into blue hydrogen. So here you just have to add a post-combustion unit to your existing plant, and then you will reduce your carbon footprint by 90%. So it's a super quick win for all the operators around the world. We see also a lot of oil and gas fields, especially offshore or petrochem installation, which are huge emitters also of carbon, which are getting revamped. And we see many steel, iron, and cement plants, especially in Europe, in the north of Europe, where we are looking to produce clean product, clean steel, clean cement, and clean iron. And of course, they are trying to apply those technologies which are not really in the field first to the industry. The first target are, of course, the industrial complexes. If you are going to build a hub for carbon capture, transport, and then storage, of course, you need to do it for the most location to be viable and to decrease the price. So, of course, those are the first target, but they are the good target as well because they are the one with the capacities to, let's say, provide a lot of carbon. Then, if we look this was, let's say, more the capture and transport part. Now, talking about storage, most of the projects are refurbishing of depleted oil and gas field for storage. Of course, if you have, for example, a gas plant producing offshore, you just have to turn your compressor in the other direction, and you are not, let's say, pumping natural gas anymore. You are just pumping CO2 injected on the ground. You already have the assets in place, so it's quite cheap to revamp your existing infrastructure to give it, let's say, a value. And in many cases, it's less expensive to revamp those existing plants into CO2 capture than to decommission those plants and to clean, let's say, the place you have been using. So that's why we see many storage capacities existing, and I think we see more and more at a small price. There are few large-scale projects existing worldwide, but most of the projects today, they are pilots, they are demonstrators. The idea for them for this project is, of course, to be, let's say, proving the technology, waiting for, let's say, business model for viability, and then to expand in phase 1, phase 2 development to be sure that they are able to clean the carbon footprint of many industrial sites to countries and to have a real impact on the market. Those projects, they benefit from public financial support. It's not super mature, as we were saying. It does not create a lot of value. So the public financing is a good support of this project. Now the question is to say, okay, how much is beneficial? We will see in the future. Now we also see private investment in the carbon footprint, and that's a little bit, for example, the case for oil and gas petrochem company, big investors. Because when they invest in solar or in hydrogen or in windmill, they do not reduce their carbon footprint. At the opposite, when they invest 1 billion in carbon capture and storage project, they are able to say, we have reduced our carbon footprint by 1 million tons a year. And there, it's really, let's say, a huge argument for them in face of the investors, in face of green activists, because they are really, reducing their carbon footprint. They are showing that they are making a better world, and of course they are quite happy to be able to demonstrate this trend. And again, it's more efficient to reduce your carbon footprint by carbon capture and storage project than using solar or windmill project. Now those projects, to be honest, we have in the database 65 projects active for carbon capture and storage. They are located in few regions, but those projects are critical in terms of technology, in terms of business, because those will be the first to make the references, to make the technology, to make the standard. So if you want to jump in a business, that's about the right time. And the question is also, what is the business model of selling carbon credits? We will see some people are starting to push this. There is huge discussion, as you know, for a carbon tax. We'll see if it happens, but if tomorrow or in 6 months there is a carbon tax, we'll see the market grow even more than what it is growing today. Again, I'm going to share a few charts that I've been using in extracted from Project Smart Explorer. And here you have the graph on the top, which is the forecast of business. As you can see, it was flat until 2020, and with all the plan of refinancing economy in 2020, thanks to COVID, we see that this market is just going to boom, and is already started in 2021, where we were on a market which was about, let's say, 1 billion a year, to a market which is already this year 3 billion, and the year is not finished. And you see this curve going up until 2024. And if it's going down later on, it's not that the market is going down, it's just you reflect the way we see the market as of today on the project. But of course, the tendency will be to keep this high rising curve. And you see, I mean, we already have prospect for 2026 project. And of course, many projects will come on top of those to push those numbers high. Again, on the top, it's a forecast. If we go on the graph below, it's what has been already awarded. And here you can see this curve going to and rising already. More than 1 billion of project has been awarded already in 2021. About 2 billion has been already awarded for 2023, which means that this business is already secure and it's already awarded. People are already working on this. The financing is done. So we see that what has been awarded is really aligned with what has been, let's say, forecasted. So we can expect that our, let's say, prediction were right, and we see the market really taking this tendency. Now, looking at who are the actors of this market, 90% of them, they are independent and nationally owned companies. So it means that this market is really driven by either private or completely public investors. The big boys or the international companies are not really part of it. They are making small, let's say, tries, but for them it's really hard to convince their shareholder to go for those projects. While at the opposite, for startups, for independent or for companies working for, let's say, their people, it's quite easy to say, okay, we are going to implement and sell this much of product. One concept also with those projects that you don't have bids for the EPC stage. It's really the conversion of the FEED contract into EPC contract. We also see in many cases that the operator is itself the engineering and the constructor and the builder of the project. So here you have to be really at early phase to be sure to be involved with the right people, because when you go to the EPC, everything is already designed, everything is already decided, so there is no chance for you to enter those projects, especially since those projects are pilot and demonstrator. They are really done in fast-track project with subsidies of government, so the financing is super secure as well. No, that was, let's say, today and the 5-year prospect for this market. No talking about, let's say, the 10-year vision and 30-year vision. That's about what we can see as of today about the market outlook. Here I was trying to write a roadmap about this market, what can be expected, what can be done. It's clear that on the next 5 years, the market will be mostly concentrated in the North Sea of Europe and in USA. That's where you will find the biggest amount of projects, the biggest project as well. That's where, why? Because that's where the government has pledged the biggest amount of public financing for those projects. Several projects will also happen in China, in Australia, for example, in Japan, also South Korea, but most of the projects will be there. and some also in Middle East. But those few places will be, I would say, the key players, the key focus area you need to address. Now, today, if we look at what is the split in terms of investment, 50% of the investment are made on CapEx, by CapEx on capture. The idea is really to build, let's say, the supply chain by the first step. So most of the investment are done on the capture itself by revamping a few facilities as pilots. One cement plant, one iron, one steel, one hydrogen plant will be revamped, and that's what we really see. It's retest to capture the CO2, how to do it, what are the great technology to capture, and that's what represents half of the market. Now, 35% of the capex, and that little bit counterintuitive, represent the transport of CO2. In fact, the storage only represents 15% of the capex. And why? Because there are so many existing oil and gas fields which are depleted that you can just reverse to store your carbon that at almost no cost or at cheap price. That today the investment is made on building the capture, but also the transport. And the transport, as soon as you need to build a pipeline, it costs a lot of money, of course. And it's really, let's say, a technical challenge to say, okay, where are going to be the hub to concentrate this carbon, how we are going to transport it, and that's where they need the many changes. About usage, just a word. Today, it's really, let's say, a laboratory test. It's not high scale, but the idea will be to use the CO2 as a fuel, as ammonia, for example, when it's mixed with some hydrogen to make ammonia, or to be used as plastic. But it's really not industrial scale. Then on the following year, I would say that this market of carbon capture will expand to all the developed countries worldwide. I mean, I hardly see how a country which is developed on the market worldwide, part of the OMC, be able to say, okay, I'm not going to revamp my industry because you can be sure that will be a carbon tax, and other countries in Europe and US will put, let's say, tax over those projects or the product they are producing, because they will be emitting too much CO2. So all the developed countries will have to revamp their facilities, and no new facility will be able to be built without carbon capture. I'm thinking about steel, petrochem, and also hydrogen. None of those applications will be able to emit this amount of CO2. Same for power generation. Usage, I think we will start to have some pilot industrial projects which will try to make something with the CO2. It will be a second market, I would say, for example, plastic. The idea, for example, it would be served for fashion, for brand designing and stuff like that, where the argument to say we recycle our CO2 will create the value. And the storage, of course, will be still using depleted oil and gas field offshore, but we'll also start to use more local cavern and saline formation, which industrial will have found nearby their location, where it will cost less to reinject and build a storage plant close by your industrial complex than to transport the CO2 back to the sea and then do it offshore. And then on let's say the period 2030, 2015, here it will apply to all the developing countries. I mean, I think it would be a global rule for you to capture all the CO2, at least at the industrial scale, and everybody will need to revamp their facility. For the usage itself here, it will be quite easy, or I would say quite viable at this point, to produce plastic or to grow bacteria and plants from CO2, or to even produce biofuel, like as we were seeing ammonia. And then the storage will transform a little bit in a way that the storage will not be, let's say, a final storage for CO2 that you inject, you close the tap, and you move to the next field as soon as it's full. Here it will be interim. It will be used as a buffer. As the CO2 will have a value, the idea will be to re-inject the CO2 we have too much, and then to reuse the CO2 for transport. So that's why you will have this interim, let's say, schematics. Now, trying to put figures on this market. Here again, it's estimation, and we try to be precautionous as always. The figure that we will need to capture and store are about 30 billion tons of CO2 equivalent per year. it's about 60%, 70% of what we are emitting right now to do today. So it's of course a big change, but as said, I mean, by few application you can already capture half of the emissions, so about 25 billion. So it means that just by adding, let's say, by the growing population, the growing industrial scale, you will have a growing the emission, and of course, the idea and the concept will be to capture always more and more CO2. So it will be about the figures that what we have to be captured and stored every year. So that's a huge volume of CO2. But again, it will be driven by few applications, all the blue hydrogen project, because you know in the future, and that's what we were discussing with the hydrogen, we will have both green hydrogen project, but also blue, because we need a huge volume of hydrogen. So here it would be a huge production of CO2. Of course, we'll have revamped all our existing facilities. So here again, you will have a huge production of carbon. And the idea is, as we will be able to reuse this carbon, there will be no harm in capturing it and recycling it. In terms of figure, business-wise, today we see that this market is about 500 million capex in 2020, which is already huge. It's not something marginal at this point. It's already a lot of projects. In 10 years, it would be 50 billions, and in 30 years, it would be around 100 billions capex investment. So those figures are huge. They are about, let's say, in 2050, they will be around 10% of what the oil and gas and petrochem business is. So it's a huge market already. It will not be this big, but it will be big already. And what is also interesting is that for those projects, most of the patents and the technology already belong to the oil and gas company, because they are process industries. They have knowledge about how to handle gas, how to have storage activities, how to manage fields and reservoir. And also, they are the one most active in reducing their carbon footprint. So they are the one developing the technology. So for many actors working in the oil and gas field, if you keep up with the same more or less actors, you can really, by the same industry, be able to make this energy transition and go to carbon capture and storage. Just to give you some estimation, I was trying to compare my estimation to some of the others. ExxonMobil is estimating that the carbon capture and storage market would represent 2 trillion in 2040. Sorry. So it's about 20 times the size we are expecting. I think they are a little bit high. Okay, I could comment this figure in more detail, but I will not go. For example, if we say global industry analysts, which are really working heavily on this market, the target to be 7 billion in 5 years, which is comparable to what we were expecting in terms of size. And more conservative, but the International Energy Agency here, they are targeting 2,000 projects by 2050, which is more or less the figure that we expect from the market. So I think we are quite aligned in terms of scale about this market. So of course, in terms of business, for you, it represents a lot of opportunities on the market itself. The last slide as a conclusion, but then we will target the question directly. The idea is to retain that it's going to be a complete new market developing fast, as you may see. And the idea is to reuse for many of those actors who are actors really of the oil and gas and the energy industry, to reuse technology brick which they have, and to build new technology brick they don't have. So we are really in this kind of critical moment where everybody is going to search for the right solution to implement, to execute those projects. And here, that's where you can step in and jump into pilot and project and demonstrator, because those projects are starting now. They are still at the, let's say, feed stage for many of them. And you can benefit from huge incentive, because the price of the equipment, the price of the solution are not really the question. The question is, will it work? Will it work in 10 years still? Will it work in 15 years? What can we learn from our processes? How can we optimize them? So of course, it's not about the price. Today, the battle is really on the technology side. We have many programs already in the pipeline over a period of 10 years, public-private programs, which is a lot of financing. Banks are really happy to support those projects. So those projects are done in no time. The demand is already there, the emission already here, those carbon emissions will not disappear. You see the demand for oil and gas is still going up, especially in the industrial and in the plastic business. So the demand will be here, the carbon emission will be here, so those projects are needed to do the energy transition. So that's a business that will never disappear. And again, that's a great opportunity for any actor of the petroleum industry to transfer your know-how at little cost, to be able to jump on those markets which are today not so competitive, and to be able to make good business. And also the financing is secured on the long term because you have public programs, for example, which are going to inject money into carbon capture for at least the next 15 years. So it gives you at least an idea of how much you can expect from this.